Here we'll look at one last example. It says when a management training company prices its seminar on management techniques at $400 per person, 1,000 people will attend the seminar. The company estimates that for each $5 reduction in price, an additional 20 people will attend the seminar. How much should the company charge for the seminar in order to maximize its revenue, and what is its maximum revenue? So we're dealing with revenue again. We want to maximize revenue, so we want to maximize R equals, I'm not going to write X times P this time because I want to have X be something very specific in this problem. Problems like these are a little bit tricky because there's kind of one little move here that we're going to make, and if you don't make that move, the problem becomes a lot harder. So I'm just going to say that the revenue equals the price of the ticket times the quantity of the tickets that they sell. So you'll see problems like this every now and then where we have sort of a baseline. They say, okay, if we charge $400 per person, then we'll have 1,000 people attend our seminar. And if we choose to reduce our price by $5, then an additional 20 people will attend the seminar. So really it's this $5 reduction in price that I kind of want to hone in on here for a moment. I'm going to choose X to be something very specific. I'm going to say let X equal the number of $5 price reductions. Price reductions. So it's the number of times that I choose to reduce my price by $5. So okay, now what I'd like to do is I'd like to write an equation for the price and for the quantity. So my price here in this case, usually in these types of problems, you're given a baseline. They say, okay, maybe we did some market research and we determined that if we start charging $400 per person, 1,000 people attend the seminar. And I really want to hone in right now on that $400 per person. I'm going to treat that sort of like my starting value. So if I start off at $400, I know exactly what my quantity is going to be. But this $400, I might change that. I might change that by, say, reducing the price by $5 or $10 or $15. So here, X is the number of $5 price reductions. I'm thinking about reducing my price here. So I'm going to take 400 minus, I'm not just going to say X, because if I reduce by, say, $5, X is 1, right? X is the number of $5 price reduction. So I'm going to say 400 minus 5X. So if X is 1, and now we can sort of check our work now. If X is equal to 1, then 400 minus 5 times 1, I have 395. I've reduced my price by $5. If X is 2, I have 400 minus 10. That would be 390. I've reduced my price by $10. So this seems to make sense. I would check your work here, check your equation before you continue on with this problem. So I have my price equation. Now I've got to have my quantity. So the quantity, I can spell quantity. All right, so the quantity here, again, I'm going to turn my attention to that baseline. Again, they said $400 per person, 1,000 people will attend the seminar. This time I'm thinking about how many tickets am I going to sell? How many people are going to attend the seminar? So our baseline here is 1,000 people will attend this seminar. So I start off by saying, okay, if I don't change the price at all, I'm going to have 1,000 people show up for this seminar. But what happens here? If I choose to reduce the price, what happens? It says an additional 20 people will attend the seminar. So 20 more people will attend the seminar. So I want to add to this 1,000 here. I'm going to add, well, each time I raise the price by, reduce the price by $5, that's X, 20 more people show up. So I'm going to take 1,000 plus 20X. So if X is 1, I have an additional 20 people show up. If X is 2, I have an additional 40 people show up. If X is 3, an extra 60 people show up, and so on. So these are the two things that I needed in order to write the equation for my revenue. So now I should be able to write my revenue function. So revenue is equal to price. We said that was 400 minus 5x times the quantity here. This is 1,000 plus 20x. So this is the function that I'd like to work with. Let's go ahead and simplify it before we start doing calculus stuff with it. So R, let's FOIL this out. Let's see, 400 times 1,000, I should have 400,000. 400 times 20, I should have plus 8,000x minus 5,000x minus here 5 times 20 minus 100x squared. So R is equal to, I'm going to write it in standard form, negative 100x squared plus 3,000x plus 400,000. So, all right, here is my revenue function. I know that I want to maximize my revenue function, so I want to find the critical numbers. Let's go ahead and take the derivative. I'll just continue in blue here. R prime is equal to negative 200x plus 3,000. So here's my derivative. I want to take this derivative, set it equal to 0, so negative 200x plus 3,000, set it equal to 0 so that we can solve for x. So 3,000 equals 200x. So it appears I have x equals, oh boy, let me just double check my math here, 3,000 over 200, I've got 15, there we go. X is equal to 15. So here is a critical number that I've come up with. X equals 15. But remember that I also want to think about my domain, because the domain is going to be kind of what tells me how I'm going to show that this is an absolute maximum. At least I hope it's an absolute maximum. I need to, in particular, determine, are we working on an open interval or are we working on a closed interval? So I'm going to look at my revenue function here, and I'm going to fall back on actually the same two things that I thought about in the last section. We said, hey, it probably doesn't make sense if your price is negative. It doesn't make sense if the amount that you sell is negative. So I'm going to say two things. I'm going to say, well, my price should be greater than or equal to 0. So that is a way of saying 400 minus 5x should be greater than or equal to 0. And my quantity, the amount that I sell here, the number of tickets that I sell, should be greater than or equal to 0. So 1,000 plus 20x should be greater than or equal to 0. So I'm going to solve each of these inequalities here. On the left-hand one over here, let's look at that first. I've got negative 5x is greater than or equal to negative 400. So x... here, when I divide by negative 5, I switch the direction of the inequality. I have x is less than or equal to 80. And over here, if I solve this, I've got 20x is greater than or equal to negative 1,000. X is greater than or equal to 1,000 over 20, which of course is negative 50. So x has to be greater than negative 50. And less than 80. So the domain, or the interval of interest here, the domain is negative 50 to 80. These are the x values that make sense for my problem. So I know at this point that I'm working on a closed interval. So that means I'm going to take my critical number along with the two endpoints of my interval. I'll plug those into my revenue function and just pick out the highest revenue because I want to maximize revenue. So my revenue function is r, and we'll start with negative 50 first. This is negative 100 times negative 50 squared plus 3,000 times negative 50 plus 400,000 here. In this case, I'm going to end up with a revenue of 0. Well, that's no good. Let's take our other endpoint, 80. Plug that in. R of 80, this is negative 100 times 80 squared plus 3,000 times 80 plus 400,000. Again, I'll go ahead and crunch those numbers. And once again, I will end up with a 0. Well, that's no good. Hopefully 15, that'll give us a positive revenue because that's really what I would like at the end of the day. So negative 100 times 15 squared plus 3,000 times 15 plus 400,000. So here in this case, negative 100 times 15 squared plus 3,000 times 15 plus 400,000. I end up with $422,500. That seems like the highest revenue to me. It's certainly higher than 0. So this $422,500, that is my maximum revenue. So my maximum revenue is $422,500. Let's go back, make sure that we're answering the question here. We're answering giving all of the necessary information. So let's see, what is the maximum revenue? We've done that, so we don't need to worry about that. How much should the company charge for the seminar in order to maximize its revenue? So in other words, what is the price? So this one is a little bit tricky here because remember we chose X to be something very specific. We said X is the number of $5 price reductions. I'm simply going to take X equals 15. Remember X equals 15, that was the value that gave us our maximum revenue, and plug that into our price function. So price is 400 minus 5X. Price here is equal to 400 minus 5X. The X value that gave us the maximum revenue was 15. So this is 400 minus 5 times 15. Here, 400 minus 5 times 15, that gives me minus 75. I should charge $325 per ticket. If I wanted to know the number of tickets that I sold, if I wanted to know that for, say, if I was trying to figure out what the capacity should be, how big of a space do I need, I could take X equals 15, plug that into my revenue function as well, or it's not my revenue function, my quantity function. So I could take X equals 15 and plug it into my quantity function here if I really wanted to know how many people are going to be attending. One last thing that I want to mention here very briefly, here we came up with a domain that looks a little bit different from some of the other domains that we've looked at. It says negative 50 to 80. It appears that we have some negative X values that are okay. And again, that is just because we chose X to be the number of $5 price reductions here. So if X was, say, a negative 1, what that represents is I'm actually choosing to increase the price by $5. So it may be more beneficial if I'm choosing to maximize revenue to raise my price rather than lower my price. So just to kind of clear that bit up, we can occasionally have a domain with negative values in it. It all just is going to depend on what X represents, and here X represents the number of $5 price reductions in our ticket price. So we have a maximum revenue of $422,500. A ticket price is $325, and we have our solution.